Welcome to the lecture 9 of Design and Analysis of Experiment. Today's topic is estimation. The content of today's presentation will first introduce the estimation concepts, then we will find out the confidence interval for single population mean, confidence interval for single population variance, confidence interval for the difference between two population means, and confidence interval for the ratio of two population variances. Now, I told you in earlier lectures that the concept of population and that of sample, they are very much related. Sample is taken from the population in order to estimate the population parameter. For example, a population for a particular characteristics y having mean mu and variance sigma square, and if you collect a sample of size n, and that is data y1, y2 to yn, then you can calculate statistics y bar and a square, and these statistics, if n is representative enough for this population, then these statistics can be used to estimate or as an estimate of the parameters. For example, mu estimate equal to y bar, and similarly your sigma square estimate will be a square. Okay. So, now another concept is that we said that if you go for a second sample, the estimate value will differ. Go for third sample, estimate value again differs. So, as a result, what happened, there will be a range of values within which the population parameters may lie. Okay. These two concepts will be discussed under estimation. As a result, estimation is of two types, point estimation and interval estimation. When we say point estimation, it is nothing but, suppose your sample average is 10, then we say this 10 is the point estimate of the population mean mu. Similarly, if sample average sample variance is 0.4 or let it be 4, then the estimate of the population variance will be 4. So, but the as sample statistics is a random variable, so it can take a large number of values. So, what we require to do? We require to have a distribution of that statistics, and from that distribution we will find out some interval with certain confidence level that okay, that the population parameter will lie within this interval with the confidence level as desired as specified. So, by estimation there will be point and interval estimation, and interval estimation it can be for single population, can be for two population, and in this lecture we will be discussing on confidence interval for mean and confidence interval for variance for single and double populations. So, single population part, you know that you have n number of data, sample data, which is y1 to yn, and then you calculate a statistics theta cap. This can be y bar, can be a square, can be something else, and then corresponding population parameters, suppose theta, which can be mu, can be sigma square, can be others for which the statistics is computed. This is point, one value you get. Suppose my data spread y1 to yn here y, then if you calculate average of this, you may find out the average value is this. So, this is y bar from a sample, this is a point estimate. Okay. Now, this y bar can be can represent mu, that means the population mean, or may not, and as a result what happened, we require some amount of confidence when we saying that the estimated value of population mean is this, that comes under interval estimation. Okay. Now, another important concept in estimation is that when you are talking about the population, whether the population is normal or non-normal. If the population is normal and we are talking about confidence interval for single population mean, then there may be two situations, that is sigma is known and sigma is unknown, and that is true for normal non-normal population also, sigma known and sigma unknown. Now, if sigma is known and n the sample size is large, that is greater than equal to 30, then the statistics, here it is the mean, will follow with certain manipulation, will follow Z distribution. You have seen in central limit theorem that y bar minus mu by sigma by root n. In central limit theorem, using central limit theorem, last class I have shown sigma by root n, that follows Z distribution, and Z distribution is nothing but unit normal distribution with mean 0, variance 1. Last class I told you. So, in this case sigma is known and sample size is large. Suppose sample size not large, less than 30, what will happen? As the population is normal, even if the sample size is small, then also Z distribution, these statistics, this one will follow Z distribution. Okay. So, what is the message here? If you are sampling from a normal population with known population variance, then irrespective of the sample size, the statistic y bar minus mu by sigma by root n follow Z distribution. Okay. Now, what will happen when sigma is unknown? When sigma is unknown, these statistics will be transformed to this. That means, what is this transformation? Sigma will be replaced by S. What is S here? S is the sample variance, sample standard deviation. So, that means there is qualitative change between these statistics to these statistics. Here sigma population variance is known, here population variance is not known. As a result, sample estimate is used, that is S by root n. So, these statistics will follow normal distribution if n is large, greater than equal to 30. If n is small, which will be the case in most of the times in this particular design of experiment situations, or when you experiment, we may not have this amount of observations, replications. So, in that case, what is the issue is that you require to use T distribution, and when you will be using T distribution, I already explained you in last class. So, it is basically Z by square root of chi-square by its degrees of freedom, and this quantity satisfies this condition. Okay. Now, what will happen for non-normal situation? If sigma is known, n greater than equal to 30, you see sigma known, n greater than equal to 30, then you can use Z distribution. This quantity follows Z distribution irrespective of whether it is coming from normal or non-normal population when n is large. Okay. Suppose n is small, Coming from normal population, n is small, sigma is known. So, we do not know the what will be the resultant distribution of this, it is not known. Okay. In case of sigma unknown, if, if sigma is unknown, you use this and take n a large quantity, large sample size. This also follows Z distribution, that is unit normal distribution. If n less than 30, that means it is some small sample size, then distribution is not known. Okay. Now, I will give you the steps. So, how to obtain confidence interval. Okay. So, confidence interval Ci, we will rather prefer to write down 100 into 1 minus alpha percent Ci. So, this confidence interval, Ci means confidence interval. For whom? Confidence interval for population parameter. Here we are using mu, population parameter mu. Okay. So, few things. Then what is alpha here? So, I told you that y bar minus mu by sigma by root n is a statistics that follows Z distribution. Z is nothing but unit normal 0 1. So, assume that this is your 0, then your normal distribution something like this. This is Z distribution. Okay. Now, what this is the quantity follows Z distribution, and here one important statistics is there y bar, which is the sample average. As if I say this is the this curve is the distribution of this, then if you take first sample, the value may be somewhere here. If you take second sample, value may be somewhere here. Third sample, value may be again here. So, like this there will be n number of samples, so n number of values, and accordingly this distribution is coming. So, any value y bar value along this line, this Z line, it is true. But you know that from theory that this mean, theoretical mean is 0. Suppose you collect a sample and this quantity falls here, this statistics falls here. Is it equivalent to 0, or is it or other way, the difference between 0 to this is sufficiently large, or it is with certain confidence it is equal to similar to 0. It is just because of randomness this difference is coming. So, if then what happened, you are basically making a distance from this to the estimated value. The distance is this. So, what is the distance that is accepted? So, that will be determined by alpha. So, alpha is known as level of significance. Alpha is known as level of significance. Okay. Now, as we are interested to the target, that is mean 0 here. So, if you deviate from 0 both side, either right or left, so that and depending on the level of significance, so some distance will be considered as acceptable, beyond which it cannot be acceptable. So, as both side it is it to be considered two-tailed case. So, this alpha will be divided by two parts. One is alpha by 2 this side, the area under the curve, and also this side alpha by 2. So, this alpha is level of significance, means that is the error accepted in this in accepting that the sample average is representative to the population mean. So, error accepted in the decision making. What does it mean? Suppose you take another sample and the mean value is such that the average sample average is such that this quantity falls here. So, you are saying that this value is far away from this. So, it is not representative of 0. So, you will not accept it, but please keep in mind that this axis is z axis where any value is true. So, by not accepting this you may commit an error, and that error is alpha. Either this side or that other left side you will commit that is the alpha. So, level of significance is nothing but the error accepted in decision making. Usually alpha equal to 0.05. What does it mean? That means 5% error. What does it mean? Suppose if you take such 100 such decisions, 95% time you will be correct and 5 times it will be wrong. So, that sense also you can use. So, in order to get this what are the steps? You see the steps here. Steps is first collect data, second is the compute the mean sample average and sample standard deviation, and then what we are doing. So, first you have data y 1 to y 2 to y n, then compute y bar and s step, that is step 1 data collection, step 2 computation of sample statistics. Now, step 3 is what we say that if the computed value fall within this range, suppose this is the lower range, this is the higher, this is the lowest lower and this is the higher one, or other way we can say this is L and this is U, lower limit and upper limit. And then what does it mean? If this is alpha by 2, this is alpha by 2, area under this curve is 1 minus alpha. So, we are accepting that probability L lower value less than equal to y bar minus mu by sigma by root n less than equal to u, this will be 1 minus alpha. So, this is that means what is the probability that the y bar, that estimate of mean population mean lies between the lower specified limit and upper specified limit is 1 minus alpha. If alpha is 0.05, this is 0.95 or 95% you are confident that the estimated sample average or the sample average is the estimate of population mean. Now, as this quantity follows z distribution, so and we all know if alpha, if we given alpha, what is this z value? This z value is z alpha by 2. Alpha by 2 for what? That is for the area under the curve right to this point. Similarly, this point will be minus z alpha by 2. So, you are looking for the interval means here L is minus z alpha by 2 and u is plus z alpha by 2, you want this interval. So, what you write then? You write like this, L is minus z alpha by 2 less than equal to y bar minus mu by sigma by root n less than equal to u. What is u? U is z alpha by 2. So, now you manipulate, what will happen? This will be minus z alpha by 2 sigma by root n less than equal to y bar minus mu less than equal to z alpha by 2 sigma by root n. So, if you further manipulate, you will find out y bar minus z alpha by 2 sigma by root n less than equal to mu less than equal to y bar plus z alpha by 2 sigma by root n. So, what is the confidence interval for mu then? Y bar minus this to y bar plus this. Okay. Now, see one example. The engineer intends to measure the intensity level on target on radar scope by using filter type 1 and assume that it is normally distributed with mean 94 and standard deviation 6.5. Construct 95% confidence interval. So, just you put what is the sample, these are the data, you find out the average from the data. The average from the data y bar, what is y bar? Y bar is 101.58. Now, consider alpha equal to 0.05. So, then z 0.025 which is alpha by 2, which this is nothing but 1.96. So, then 1.96 into what is sigma? Sigma is 6.5 divided by root n, that is 12, less than equal to mu less than equal to 101.58 plus 1.98 into 6.5 by 12. So, this quantity ultimately will give you 97.90 less than equal to mu less than equal to 15.26. So, this is the confidence interval for mu. What does it mean? This interval 99.90 to 105.26, this interval contains mu with a confidence of 95%. Okay, this interval contains mu. So, then what is the point estimate here? Point estimate is 101.58. Interval estimate is 97.90 to 105.26. Now, see what happened, this one falls within this definitely. Okay. So, this is the concept of point estimation and interval estimation. Now, now come to the second one, that population variance. So, single population variance. So, here what you will do basically. So, if you can recall the last lecture where we have explained that we have created n minus 1 by sigma square into s square, this quantity, and we say that this quantity follows chi-square distribution with n minus 1 degrees of freedom. Chi-square distribution with n minus 1 degrees of freedom. Now, you do one thing, you assume that this is the theoretical chi-square distribution. So, chi-square, then this is the PDF of chi-square and it is n minus 1. So, okay. So, suppose what happened that this is the chi-square distribution. I do not know what will be the exact nature, but this is the case. So, in that case what happened, we are interested to know the what happened actually, I am repeating. So, your population variance is sigma square, you do not know it. You have collected a sample, sample variance is s square, this value is point estimate. So, if you collect several sample, s will change. So, you require interval. So, now you may create an interval like this here and here. So, this side is alpha by 2, this side is also alpha by 2. Then what is this quantity? Chi square n minus 1 alpha by 2. Write to this. What is this quantity? Chi square n minus 1. Write to this 1 minus alpha by 2. Okay. So, again what you do then, probability that this less than equal to n minus 1 by sigma square into a square less than equal to this is 1 minus alpha. So, now you manipulate this. So, what you want from here, you will find out that sigma square you want less than equal to, and that will be n minus 1 a square by chi square n minus 1 alpha by 2, and then this will be n minus 1 a square by chi square n minus 1 minus alpha by 2. What is happening here? Denominator n minus 1 a square, n minus 1 a square. Okay. That is numerator. Then denominator here chi square alpha by 2, this value, this is a large value. Chi square 1 minus alpha by this value, this is smaller than this value. So, this quantity will be smaller than this quantity obviously, and this is the interval with. So, now see this for the same example, we are interested to know the confidence interval for population standard deviation. Okay. So, you just put this all those values here, you see 11, 7.2 by this. So, this is the interval for variance. Now, if you take the square root, you will get the confidence interval for standard deviation. Okay. Now, very quickly I will just go for two population means. So, please remember here we are all are interested to know the random variable of interest, the statistic. Okay. So, what happened? So, when it is one population, random variable interest is one population, random variable is y. Two population, random variable y1, y2. So, now in two population means our interesting one is we want to test whether y1 bar minus this is what is our I can say that resultant random variable. From the objective's point of view, we want to see that the difference between two population means. Okay. So, this is our random variable of interest. What do you want to know? You want to know the expected value of y1 bar minus y2 bar, that will be mu 1 minus mu 2. You also require to know variance of y1 bar by 2 bar, it will be variance of y1 bar plus variance of y2 bar, because y1 bar y2 bar are coming from two different population, they are independent. So, this will be your sigma 1 square plus sigma 2 square when the two population mean is mu 1 and mu 2 and variance is sigma 1 square and sigma 2 square. Here you have seen mu and sigma square for one population. So, is it correct that y1 bar and y2 bar will be this? If it is y1 y2, this is correct. If it is y1 bar y2 bar, it is not correct, this will be by n1 by n2. Because I told you in last class that if y is normally distributed with mu and sigma square or no y, then what will happen if y variability is sigma square, then the y bar's variability will be sigma square by n, that is what you are writing. So, that means this is sigma 1 square by n1 plus sigma 2 square by n2. Now, from central limit theorem you can write that y1 bar minus y2 bar minus its expected value is mu 1 minus mu 2 divided by the sigma by root n component, that is sigma square by n1 plus sigma 2 square by n2 of square root. This follows Z distribution. Okay. This follows Z distribution for large sample size, small sample size, if whatever may be, if it is coming from if the sigma 1 sigma 2 are known, coming from normal population, both the population are normal. And then using the concept that is the confidence interval, that probability low less than equal, this value lies within the lower limit and upper limit, that will give you the interval. Okay. So, but these two population means is a very important concept, and the confidence interval calculation is also very important, because in design of an DOE this subject, what I will see that it is every time we will see that there will be concept of hypothesis testing and confidence interval estimation. That confidence interval for one population, then two population, then more than two population kind of things. That means one label, that means two factor with two label, it is two population, factor with three labels, three population. So many come, then more than three, that is the multi-level case. So every time we will go for confidence interval, and as well as the, what is the other one, that is the pairwise comparison, simultaneous confidence interval, many things will be discussed. So okay, so for the time being, this much. Although I said that we want to cover up to two population variances, but next class I will explain. I will start this one, two population confidence interval, two population mean, and ratio between two population variances. Thank you very much.